Hi, hello everyone. I suppose we should get started. It's already 4:05. Hi, hello. My name is Dariusz Wawer. I'm a technical project leader at Pretius. And today I'm going to talk with you about microservices. And as the title says, the microservices are the answer. But what is the question? So I suppose this is no longer a new subject. Microservices have been around for let's say 9 years now, so they're no longer something new. They are just a tool, let's say, that we use maybe every day to solve certain problems. So yeah, presentations about microservices are kind of cliche right now. Nobody wants to hear about microservices anymore, but still I believe that there's a little bit more that can be said about microservices. So in this talk I'm going to tell you a few things about microservices. Some of them you probably know, some of them I hope you don't. So one thing to note, I'll be considering only single factors in a given subject, and when you approach a real-life problem, you have to consider all the factors when you're creating your solution. So keep this in mind when you're facing your own microservices problem. And for start, how many of you are junior developers? Okay, so show of hands, who's a junior developer right now? Okay, not many. Who's a mid-level developer? Middle? Great, most of you. Okay, so actually I was preparing this whole talk aiming for mid-level developers. I hope that juniors will be able to get something out of it, but mostly it's for middles. And who's a senior developer or an architect or, okay, what are you doing here? Seriously. Okay, so my main aim is that after this talk, when you're facing problems, when you're creating your own solution, you will have several more things to think about, okay, when creating your own solution. So I suppose we should get started. Let's start with some basic information, Microservices 101. So what is a microservice? What is a microservice? Seriously, what's a microservice? Okay, no one. It's just an application, right? It's just an application written in any language. However, it's microservice, so this should be a small application. It's got an API. It's the way all other microsystems communicate with it. It's got some code inside, of course. It's an application. And sometimes it's got a database. So what's the difference between a microservice and a service run in a monolith? Very little difference, okay? They both expose some kind of APIs in their controller level, sorry. Okay, thanks. Okay, but the scope is different, okay? So microservice does certain things, not many things, in a single domain, while services or controllers in monoliths mostly cover one whole domain, sometimes even several domains, okay? So when you think about microservice, you think small. How can I do this small part of my code well, properly, perhaps? And if a microservice does one thing, then this one thing can be perhaps developed quickly, okay, efficiently. So that's something to keep in mind. And what does this mean for testing? Okay, so developing is just part of the process. There's testing, which takes place during development and also after. So when a tester approaches a microservice, he's gotten a simpler job than when a tester approaches a monolith, okay? So microservice is small, so it's better. There's a lower entry threshold for testing a microservice by a tester than to testing a monolith. And moreover, since the microservice usually has just the API, it's actually much easier to use external tools that automate the testing of this API, okay? And this also works for developers, so it's much easier to achieve a high coverage for, with unit tests of your microservice than for a monolith. Okay, what else? Since the microservice is simple, the tests are also simple, right? Okay, let's go to another subject, also in the one-on-one section. So what's an orchestrator? And what makes Orchestrator different than an application server, okay? So in Orchestrator, you have microservices, perhaps many instances of a particular microservice, while of course application server is just a process that runs your application, right? So what does this orchestrator give us? What are the advantages? Okay, so each microservice is a separate application. If it fails, only this application fails. Okay, other applications in that orchestrator are not affected. As I said, the orchestrator allows you to scale your application. Okay, so a given microservice can be run in multiple instances, and the orchestrator controls it. Okay, actually the administrator or DevOps person or even developer controls it, right? But the tool that is used for the controlling is an orchestrator. And it's great that you can scale your application. However, when is such scaling possible, right? So can you just take your monolith application, run it in Kubernetes or something? Will it run? Will it work? Seriously, that's an easy question. These are, you know, mugs and umbrellas here. So if you take your stuff, great, right? It won't work, okay? Because it's not that simple. When you create a microservice, when you create a microservice-oriented solution, you have to keep it in mind that you have to code in such a way that this application that it will be possible to run this application in an orchestrator, and it will be possible to scale it, okay? It's not that simple. Right. So, what else changes when you choose microservices over a monolith application? The DevOps. The DevOps section is very important for microservices especially. So you can easily, quickly deploy microservices using those tools. Usually it's just one click somewhere and it all goes to testing, for example. Or another click, it's in production already. So everything is done automatically. And can this be done with a monolith? Can you have a monolith that is deployed in one click on production? Can you? Another easy question. Yes, you can. Of course you can. But how many of you right now have monoliths that are not deployed even on testing using continuous integration? Seriously, all of you? All of your applications right now are deployed on tests? Your big old legacy monoliths, 10-year-old applications? Okay, great. Actually, I still have some applications that aren't deployed that way, right? So they have to be deployed the old way. So with a microservice, these are a must. With monoliths, they are optional. Okay, what else? With a monolith, you could just open this log file in your var logs, etc., and you could see what's going on with the application. With microservices, you can't do that because you have like 3 instances of 9 separate microservices. You would have to go to Kubernetes or anything else, open each pod and see the logs. Well, that's not very convenient, is it? So for a microservices, once again, those tools like Prometheus, like Grafana, like Kibana, etc., are a must. You don't have to have them with monoliths, but you do have to have them with microservices. Okay, this all sounds fine. There's one important thing that all developers know, I suppose they should know about microservices: debugging. So debugging microservices is much more difficult. right? This is a serious disadvantage. So with a monolith, you could just run the monolith, attach your debugger in your IDE, and you are good to go, okay? No bugs were difficult. Okay, some bugs were difficult, but still, it was easier. With microservices, it doesn't work that way, so you can debug a single microservice if you're lucky, and if it's the, let's say, the lower level microservice, but it's not always possible. So you have to keep this in mind, and there are some more drawbacks, okay? There are some overheads, for example, that microservices introduce. So you use more RAM with each jar that is loaded separately by each microservice, and Spring jars can be heavy. You lose some RAM, okay? You lose some CPU, lose some processing time for just sending and parsing those HTTP REST JSON requests, right? So if you look at the problem, look at this from this point of view, monoliths are better. There are just Java calls, they work internally, there are no overheads, the jar is loaded only once. So from this point of view, it's actually not that good to have microservices-oriented architecture, but it scales better, right? Okay, so let's go deeper, a little bit deeper. So I told you a little bit of basic knowledge about microservices. Now, how do you approach designing a microservice? Okay, this is, it's getting a little bit more complex, right? So first of all, we've already learned that a microservice is in several ways similar to an application, a normal monolith, but it's smaller, okay? So how does creating a microservice differ from creating a service bin in Spring? How does it differ? This is also a simple question, actually. I don't know if you have the same experience, but in my days when I was developing most of the time, when I had to create a service bin in Spring, I would just, create a new class, several clicks, then write the service annotation, write several methods, and I was good to go, right? I've already have a new service. With microservices, it doesn't work that way. It's not that simple. You have to create this new application, set it up somewhere, and it's kind of a side effect, but when you create a new microservice, you actually put a lot of thought into this particular service, okay? So you design the API. You design the API first, okay? So you determine what this microservice should do. Whether it's going to, let's say, serve some objects or fulfill some business actions. But you really think about it. And it's good, it's better. I think that's one of the most important factors that make microservices architecture cleaner than a monolith, okay? Just a quick reference. How many of you were just in the pathology presentation, just previous session? Okay, some of you, great. Then you know what this Spring object bin org leads to, okay? This is a serious problem. With microservices, it doesn't work that way. You have to put more work into creating each microservice, and you think about it more, and it is cleaner. It is cleaner, okay. One tip I have when designing the API of a microservice, sometimes, not always, but sometimes you can think generic, okay? So you can try to think about your microservice, think about your requirements, and you can try to put a little bit more into your service that it possibly, in the nearest future, could serve some bigger purpose than it does initially. So, for example, in this first table, we have a very simple, let's say it's a database table, okay? It's the underlying data model for your microservice, and it's a template generation service. So it's got an ID, all, primary key, etc. All databases have them. It's a name, activation confirmation. There's the template body, and some additional information. what you could do with very little work, okay, at this initial stage, you can add some more information. For example, let's add status. It'll be active all the time, okay, no problem. You can add the type, system, you can add the information about the engine which will be used to process this template. And when creating the service, when you're already coding it, this doesn't take much more time, okay, doing this. While if you had to extend the service later on, you would have to revisit it, you would have to change the code that already exists and work, you would have to then retest it, etc., etc. And just to let you know, I do realize that this is not always possible, and this doesn't always make sense. But with some experience, you can determine when creating a new microservice whether this will be extendable, expandable, or not, and take appropriate action. Okay, enough about single microservice. Now we are getting closer to the most interesting part, designing microservices. Okay, so the entire microservice solution. So once again, how do you design a microservice-based solution? The answer is you actually design it quite similarly as you would design a monolith. Okay, so you have all those layers. So there's a business layer, some top-level microservices that do some business operations. You have those data layers, which do data operations, like DAOs and mappers and whatever you use, whatever library you use in your monolith, okay? And you sometimes have those technical integration layer microservices, which do kind of a specific work. So, how does it differ from creating a monolith? Each of those, whether it's business layer or data layer, has its own layers inside, okay? So the code is separated not only to those microservices, but also internally in each microservice. And it actually creates order, okay? So once again, you can't make a service like bean in here that would use a bean from here. You can't, you just can't, it's impossible. So you have to plan, you have to think, you have to consider how to do certain things, and it results in cleaner code, in easier to maintain later on architecture. Okay, but remember, always remember that creating something is easier than debugging it, okay? So debugging is usually twice as hard than coding. So this also applies to microservices. And as I already said, it's a little bit more difficult to debug microservices because you simply can't use the standard debugger. So let's take a look at this picture. We have several blue lines which represent request propagation across our microservice solution. So if at any point of this request propagation an error occurs, you want to know exactly what happened, okay? So that you can determine what the problem is and fix it, okay? And there's a rule, the journalists use this rule, but it's actually quite applicable to our problem. It's a rule of 5 W's and H. So it's who, what, when, where, why, and the H, how. So, for example, in our case, it may be which user used what kind of operation, when this everything happened, and by when I mean each request from each microservice, okay, so the order also, and which process, the contents of the request, so you can debug it, okay? So without this, you actually won't be able to handle problems, especially in production, right? So what do you use to achieve this kind of information? Also, there are lots of tools. Right now, nowadays, they are very mature and very reliable. So you have tools that, for example, put correlation ID in each of those requests. There are great tools for logs viewing and searching. There are metrics. There are circuit breakers, which also help. Okay, so as I said before, these are an absolute must with microservices. Okay, we're approaching we're getting as deep as I'm going to be in this talk. Okay, so session. In monoliths, once again, session is quite simple. You store it in memory. If you want to, you can persist the session in a database of sort. In microservices, session is not that simple. Okay, there are many microservices. Most of them need sessions. So how do you handle session in microservices-oriented architecture? The first solution is try to, okay, it's obvious probably, but let's say it anyway. You can try to not have session at all. It's rarely possible, unfortunately. But for some operations, like let's say search operations, you may skip the session. However, there's always going to be this requirement that you have to log which user searched for what, or you have to have personalized results. So you're going to need the session anyway. So how do you handle session? Two ways are possible. They are sometimes used in combination. So first of all, you can use a token, for example, Java Web Token, that will store some information for the user. Okay, so some user ID, some basic permissions. This is a client-side session. It does introduce some overhead to the client because the client has to, refresh the session, etc. But it is doable, and you can store, well, pretty big amount of data in this token, but not too much. Okay, so you probably don't want to have, let's say, 10 megabytes of data sent in header of each HTTP request, right? You don't want that. And if you have to have some more information or different information, information varying from service to service, then you can use a state database. For microservices, it's usually some NoSQL, some JSON repository. For example, Redis is a very common choice. It's fast, it's scalable, and as you can see here, only those services that actually need this data will call the database. Okay, the token is usually propagated across all requests, but only those services that need the data call the state database. Right? Okay. Going to another subject, also very difficult in microservices, in my opinion. Transactions. Okay, so with monoliths, transaction was simple, and it was simple not because it is simple, because it's a huge problem, but because we had tools that handled the transactions for us. Okay, so we just use this transactional database, and it's done all the work, right? Everything. You could commit, you could roll back, you could have a nested transaction if you wanted. It worked. With microservices, well, let's say this. Distributed transactions are difficult, okay? They are difficult. Distributed rollbacks are even more difficult, okay? Sometimes there are nearly impossible. So, there are some solutions, Java Transactional API, for example, but they are very complex, and if you can, you may try to avoid them. So, how to perform a transactional operation in microservices? These are some general tips that I think you should consider when creating your own solutions. So, first of all, you choose a single microservice, which will be the orchestrator of the transaction, so that it calls all the services that are part of the transaction, that it's not a tree. This is a root, and those are leaves, okay? Not more complex graph. Secondly, you determine the order of operations that you have to do. So a general rule would be that first, you do those operations that are simplest, and that can be rolled back easily. So, for example, these are RESTful APIs. You can't actually roll back them per se, but you can create an object with some draft or something status, and then you can delete the object if you have to roll back the transaction, right? And the most difficult operation in the transactional chain should be the transaction that you can't, or that is very difficult to roll back, right? So if everything goes smoothly, you create objects here, create them there, and just do the logic here, everything went well. Okay, so if, for example, this fails, let's say this fails, you can delete objects here. What if you started with this? So this goes well. You then create objects here and here. Oops, got an error. Delete here, can't go back, right? So that's something you might want also to consider with your own solutions. And another very connected topic to this one are transactions with legacy systems, okay? So the previous one was actually a similar case, right? So you probably saw that this was an technical layer microservice, then was an external system. You can just skip this, okay? I know it's not a very good idea to say that you don't use microservices in a microservices talk, but seriously, when you're transitioning, when the organization you're working for, you're coding for, is transitioning to microservices-oriented architecture, it's tempting to throw some microservices here and somehow connect them to this monolithic logic here. Consider not doing that, okay? Even if you have to just add a little bit more here, do this whole in one transaction here. It'll save you some time, most likely. And finally, when the organization is mature enough to throw out this element, then you create here whatever you need that will fulfill the same role, okay? So let's weigh out when and when not to use microservices. What are the factors pro and against when you have some requirements and try to determine your solutions? So factors for are pretty obvious, okay? So anyone, all people talk about companies that actually, for which those factors are very important. So large traffic, okay? Microservices do scale well, okay? They handle large traffic very well. Stateless, if your application doesn't require much state DB calls, then it's a good idea to put it in a microservice. When there are clear borders between domains so that you can keep this architecture of your solution clean and possibly simple, and fast-changing environments. So this is actually more complex, but it's much easier to even rewrite an entire microservice than do some very deep modifications in your monolith, right? It's also because of the amount of internal connections between beans that tend to happen in microservices. So what kind of applications are these? Search engines, some data processors that use CPU heavily, let's say video streaming services, anyone? Right? There are some major players in this field that use microservices. Let's say maybe cab drivers support. That's also quite a good example. But when not to use microservices. So when your application is strongly stateful, when there are lots of calls to this state DB, when the data in the state database changes quickly, rapidly, and very often. When there are many transactions, especially, okay, I've stated it here explicitly. When your applications handle money, you may want to consider putting just maybe the part that handles money and a little bit around it in this domain in a monolith, okay? It will make it simpler. And those applications are some BPMNs, some batch processors, and various money handlers, okay? Money transaction handlers. Now, I have some ideas about the future. I've tried to show you the differences between the microservices and a monolith when designing, creating the application. And I think that perhaps those approaches can become a little bit closer so that they could coexist more efficiently. So I want to share with you two ideas that I'd perhaps one day like to see in production somewhere. And of course, feel free to discuss them with me. There'll be Twitter links later on. So please, if you have some interesting comments about this, then just reach me via Twitter or after this presentation, whatever. As I said, designing microservices and a monolith, it's quite similar. The same layers, right? Technical, business, data, databases here, databases there. There is some similarity between those two. So perhaps one could unify the approach to Spring beans in a monolith and microservices. So, for example, they would be visible as such in various DevOps tools. So right now, when you have a request flow like this that reaches a monolith at one point, then what happens here is like magic. It's a absolutely total black box. This can be doing like 5 times the amount of work of all those microservices, and you have no idea what it actually is, right? So I think it would be a little bit better and easier for the programmer in such situations if you could see inside the monolith. Okay, so if you saw a service bean, like you see a microservice in those DevOps tools, even maybe view the contents of each request passed here inside in JVM. I think it would be possible to do this, especially, well, Spring just, you know, when you see a stack trace, Spring just introduces like 20 lines of stack with each call between beans. Let's just put 2 more there, okay? And you can achieve something like this if you do this. I think it would be very, very convenient for debugging if you had something like this. Okay, so and one more idea. So right now, orchestrators look like this. You've got, for example, Kubernetes, and it spans across multiple physical servers, and some microservices are run inside. Some of them are exactly the same, but with different amount of instances. Some are different, only served in one server, right? So, what can we do with this? And it was, I think, 2 years ago that Bruce Tett's Pendulum talk, it was at DevOps, I think, got me thinking. He said that the programming community swings like a pendulum from distributed architecture to centralized architecture. It's happened several times across last, well, tens of years, probably 50 years. And perhaps it's going to happen one day again. So right now we have dedicated tools that run micro applications in cluster. However, perhaps we could have a tool that would make, let's say, a Spring-based monolith an orchestrator, just a random name here, yeah, Spring Cloud Orchestrator, that would actually manage your monolith application across many physical servers. Actually, there were attempts for doing something similar. It was Corba and some remote calls. It didn't work very well, but it was quite a long time ago. So during those, let's say, 15, 20 years, those technologies have matured. And perhaps now, something like this would be possible. And what would be the advantages of this solution? First of all, a developer could run this whole Spring application on his own machine in its entirety, right? He could debug it. The testing would also be easier, convenient. In general, the DevOps overhead that microservices introduce would be significantly diminished with such solution, and the overheads. Okay, so those calls between those services, those would be just Java virtual machine calls, no overhead. Okay, so the advantages, I hope, are clear. There will certainly be some disadvantages. For example, this will actually be a very complex solution that would be able to mix Java virtual calls with network calls across several machines. But still, I think nowadays it is possible. It would take a lot of time, but it is possible. Do the advantages and the cost outweigh the cost and the disadvantages? I don't know that. Okay, so let's do a full circle right now and get back to the original answer, microservices, and let's think about what's the question. So I just put it here for laughs. So the question would be, what will you use for large, scalable, large traffic, stateless, rapidly developed, fast-changing, agile solution? And then the answer would be microservices. What if only a few factors of those applied to your problem, to your solution? What if there are factors that are against microservices? Probably the answer would be different. So that's probably the main point I want to make. Once again, microservices are not the golden hammer, not the silver bullet. They are a powerful tool that can solve many problems, but when incorrectly used, they can generate actually even more problems. So when designing a new solution, always consider carefully all those pros and cons and whether microservices are really applicable to your current situation. So what will you use in all other than the stated in the original question situations? It depends, okay? Keep this in mind. Okay, that'll be the end. Thank you very much for listening. If you have any more questions, if you disagree with me, if you want to discuss something, please find me after the talk. Or do we still have some time? Sorry. I suppose we do. So perhaps there are some questions from the audience.
Okay, what do you do when your transaction in microservices fails to roll back?
I'm sorry, once again?
What would you do if your transaction in microservices, which was failed, and then you tried to roll back it, and the rollback fails too?
I'm very sorry, I actually can't hear you. I suppose you all hear him very well, but I don't. This is the speaker. I can.
If you try to roll back the transaction and that rollback fails, what would you do?
What would I do if a transaction failed?
Yeah, and the rollback fails.
Okay, and the rollback failed. Well, I'm not quite sure how this is related to this talk. In general, there are two options. First of all, whether I foresaw the situation and handled it, and if I didn't foresee it, well, it happened. So I can't really do much about this. I suppose with proper logging and let's say some defensive coding, you could probably manually roll back this transaction. That's a possibility. However, the main aim of programmers should be do not let this situation occur. I don't know if this answers the question, but I suppose these are the options.
Okay.
Okay.
Hey.
Hey.
Do you hear me properly?
Yeah, I guess.
Okay, I might have a similar question. On one of the slides you mentioned that you first call a microservice that does the last work that is possible, and later you call a microservice that is heavy in the context of rolling back microservice, right?
Okay, more or less. I didn't mean heavy or
use case is you call microservice 1. This microservice puts data into database. And you call this heavy second microservice, right? Second microservice fails, so you want to roll back the first transaction, so we call it.
Oh, yeah, that's the idea.
Okay, but what if the state of the first microservice changes between the first call and the call to the second microservice? How do you defend against that? In the context of rolling back, do you have like any defending strategy? Do you know what I mean?
Yeah, I do. Well, these are very complex problems, unfortunately. As I said, you might want to add a flag to this object you've created,
okay,
so that you know that it's not, let's say it's created but not confirmed. It's not entirely committed. That's one way you could handle it. Second, make sure in your flow, in your application, that such situations do not occur. So you can put certain guards in your other microservices, in your code. For example, you could perhaps use queues for this, so that no other modification to this object is done before the first process, the entire commit process, actually completes successfully.
Okay, so I need, for example, to instruct the orchestrator microservice, right, to handle the transaction, like block first microservice, prevent first microservice from updating a newly created object before the transaction is committed, we can say.
Well, you're doing those air quotes. Yeah, with air quotes, I'd say yes. In real life, these are very complex problems, okay? So I don't know, you probably have some background because of which you're asking this question. So in general, order management, order execution is very difficult. I mean, it's like one of the most difficult things you can do. And this includes transactions. So
okay, so I need to handle it by myself. There's no like simple defending strategy against that.
Simple? Well, I don't know if there is one. If there is, please share it with me. I can't think of a very simple solution that would defend against it.
Okay, thank you.
Remember to check out my Twitter account. Remember to check out my company's page. And again, talk to me if there's anything you think is worth talking and asking some questions. Thanks very much.